The Kweek Dirtee railroad is designed as a mid-section of a short line, single track and with passing sidings. The best way to probably look at it is looking at the circuit board or the control board right here. It consists of 8 blocks which are above board on top of the table, and an under table holdover loop, which allows me to store 6 trains here, dispatch them, and there's a crossover section that allows me to then route them in either direction. Here we see this is block 1, block 2, block 3, and block 6 have sidings, which allows me to either run trains around each other or pass in opposite directions. Looks like we have a train stop at the station up at the top there, which presumably should continue on at some point. Now, this can all be controlled manually. I can run maybe 2 trains by, operating the switches here, and that's why it's waiting for a switch to be thrown. By operating the switches here, each of the switches, by the way, the ones for the blocks, really route either this power pack or this power pack to the track, and in the middle it's a off position. So what that allows me to do is set this power pack for a typically a western direction, that way, where this train is going, and this one for an eastern direction. And then that allows me then just to basically switch the power pack from one pack to the other, and that controls the direction of the train, rather than trying to switch the pack and have perhaps other trains affected. Now, on top of all this is a computer which allows the trains to run automatically, which they're trying to do right now. And this is a recent addition, and this is really the crux of what I was going to try to show in this particular segment. Those trains are all scheduled now. There should be 4 of them to run a certain pattern. Like this one here is waiting for that one to pass in that direction. Okay, and then he will continue on to the end of the line. And there we go. There's a freight, for example, going eastward. Now this is the stretched out version of the layout. Obviously, as you see on the top here, it starts with block 1, which is under that bridge, which comes around the bluff, comes over this train now is in block 2, and you can see it's lit up here. Then it comes, block 3 is the station area, block 4 goes around the bluff, block 5 up the hill, block 6 is the section on the top of the hill, and then it runs into the edge of 7, and then 8 is behind the scenery. And that goes downhill, just like block 1 goes downhill. The two form a double track, which then comes around underneath the front here. And here you have the holdover tracks. I don't know if you can see those from where you are now. That allows me to stack up to 6 trains. Now, the way the bottom works is it's unidirectional. It always goes from right to left. In other words, it comes in on the track, it goes all the way down to the end, and then comes around and branches out into the 6 holdover tracks, which are indicated here. And then there's an exit track here that then goes to the crossover, which then routes it one way or the other. The computer piece of this is an Arduino. It's the largest one made. I forget the number, 2065 or something like that. But it's useful because it's got about 50 some odd ports on it. And in operating this thing, you really need a lot more. So there was a design issue here to try to figure out what are the minimum requirements needed to actually run this railroad. And the way we figured that one out was basically to buy 2 8-relay boards. So I have actually 16 relays back here, which then control switches, 4 of those, and those switches are the switches on either end of the sidings. The power itself, and the power actually is broken into the half the layout. So in other words, the first half here up to block 4 is controlled by one bus, which is fed by one of the relays, and the other half is by another relay. So theoretically, and I haven't done this yet, I should be able to run something in this block one way and something in this block the other way. Now, all this is because HO gauge is a 2-track system, and the direction depends on the polarity of the track. So that I believe it's plus on the right side means forward, so plus on the left side would be back. Now, I don't trust my memory on that one. Now you can see that the pattern is continuing on with another train coming back this way, and we shall then proceed from there. Now, a little bit, I guess, about the programming. The Arduino has to be controlled by something. It does certain functions by itself. One of them is the signals and the automatic train control. Now, the automatic train control is actually, there's only 4 working gaps on the top of the layout, and they are another 4 of the relays off the relay board. What they do is basically they're on either end of the sidings, which allows me to run a train into the siding and stop it there. There's a gap right here in this section here, and one on the other end of the siding that can be turned on and off. It's a little bit complicated, but what the way it works is the switch itself, the turnout, okay, actually controls the gap, so that if the switch is set in the wrong position and a train is coming into it, it will stop. In other words, it won't go ahead and derail and ruin the whole thing. The other thing is there's also an additional relay in there that if the block, or actually the next 2 blocks are busy, that relay will operate and turn off either one of the 2 tracks going there. So it's actually controlled by 2 different things. So you have the block, the turnout, which is really one of the relays, and the block occupancy, which is the other relay. So 2 relays control each of those. And that's half the relays right there. Now, to dispatch the trains from down here, we also need relays, and right now only 4 tracks are operative, and they take up 4 more relays, and that ends up being the entire 16 relays. Now, what I'm going to do down here, by the way, is to kind of multiplex them a little bit. Take one of the relays and turn it into an either-or kind of a block select thing, where either the first 3 or the second 3 connections will be active. So that way, that gets me all 6 blocks. And again, that's a future addition right now. But temporarily, we run on 4, and that's all you roll, I guess. On top of the Arduino, you have to have some means of telling it what program or what pattern you want to run. And the patterns, by the way, are kind of a microcode that I've written. It's like little 2-digit codes that do things like sense a train, then it's in a block, or well, I should mention that too. The lights showing the occupancy of the train, if you can see that or not, see that train just went from one block to another. Are routed through what they call a current detector. Now, a current detector, for those with electrical knowledge, is nothing more than a bridge rectifier, and it's wired in such a way that the current goes through 2 of the diodes this way or 2 of the diodes that way. And diodes have a voltage drop of 0.7 volts, so that 2 of them ends up being 1.4 volts. And what I do is I bridge this lamp, which, by the way, is nothing more than a Christmas tree lamp, and it's rated at 3 volts across the bridge, so that if a train is drawing current through this thing, it will also create a voltage drop across the bridge and light up the bulb in either direction. Now, also associated with each of the occupancy bulbs in each block is a thing called an LDR, or a light-dependent resistor. Now, when it's dark on this thing, the resistance is just somewhere in the megohm range. But when there's light on it, it drops down into like 100 ohms or below. And this can be used as an input to the Arduino as a sensor. And that's exactly what happens here, is all 8 blocks and the 2 sidings go into input ports on the Arduino. So it knows basically where a train is. Now that works on the top 8, or actually 10 blocks, but down below, I have the lights, but I don't have them wired up with the LDRs yet. So some of the sensing is done on a timer. In other words, if a train comes in this way, it must go here next. So internally, the Arduino lights up the non-existent bulb and holds it on for a certain period of time, and then in the next block, and so on. So part of this thing is deductive logic as opposed to actual sensing. Eventually, I'll put the actual sensing in, but for right now, this is the way to do it. Now, the Arduino keeps track again of where the trains are. It's got, it also does some logic as to what blocks ahead are occupied and such and such. And we can see right here that something happened. Apparently there's a derailment here because it's been lit up for quite some time. But what the Arduino does, and this happens to be fortuitous at this point, is it sets this guy here as a red signal. And you can't really see it right now, but this train is actually waiting for that red signal. So in a way, the layout itself is self-correcting. If something bad happens, the train stops. You're probably wondering about the laptop over here. The laptop actually provides a couple of functions. One, it allows me to write the program for the Arduino, and that is sent in. The Arduino, by the way, sits behind all this stuff, and it's connected to the laptop with a USB connection, USB-A on this end and a USB on the other end, and allows me to write the programs there in a modified C programming language, similar to the C when it was first invented. There's not a lot. It's not like C++ or C# or any of those things. It's like basic C. Once the program's in there, it's set up to communicate with the laptop also via the USB connection. And what you see on the laptop is another program written in C++ for Windows that displays the layout diagram here and echoes the lights that the Arduino sees. So, if you can see it or not, well, here's one lit up. In other words, block 12 over here and block 6 seem to be, or is said to be occupied. Now, this one isn't, which means we do have an error here. In fact, it's probably a good time here to for me to take a break and find out what's going on.